like you're used to nice smooth curves. If they're continuous, then there's a tangent line. But if it's not continuous, okay, the slope there, and I can even make this like them kind of look the same. But if it's not, if they're not continuous, it's not differentiable at a point either.
Okay.
So it's like, just because something is continuous doesn't necessarily mean that it's differentiable. Excuse me, but if it is differentiable, then it is continuous. So this is a yes or an always, and this is like a maybe.
Okay. So to determine if it is differentiable from a continuous function.
Well, you would first try to figure out if it's continuous or not, because you're generally looking for like excluding something.
Okay.
So in that problem that we were looking at, to determine whether something, and let's snip it in now. If I can get some, come on, need some more room. There it is. If a equals 5, so that's 5x, and b equals 4, okay, you first have to see if the first thing you check is whether it's continuous. This is for part C. First, if it's continuous, then you would check differentiable. Because if it fails continuous, you don't have to go any further. So to check continuous, you evaluate at x equals 0. And that was let me do that here. So that was sine of 5 times 0 plus 4 cosine 0 equals question mark 5 times 0 plus 3. So that's sine of 0 plus 4 cosine 0 equals 0 plus 3. So this is 0 plus 4 equals 3, and no.
So it's not continuous, but didn't you say that could possibly be differentiable?
But if it's not continuous, then you know it's not differentiable.
Oh, okay.
Because like I was trying to show you, is like they could have the same slopes, and this isn't a great drawing. Let me try to draw. Let's say they have the same slopes.
So then what about the maybe from continuous to differentiable?
Well, then you have to check differentiable. So let's just say this was 4. 4.
Oh, I see. If it is continuous, there's a possibility that it's differentiable, but it doesn't have to be.
That's right. That's right.
Okay, I got it.
and then you would check differentiability if you wanted to.
Got it.
I believe you'll get a question like that on the exam. Usually it's like solve for the values of a and b that give you continuous and differentiable. And
then if it is differentiable, it has to be continuous, right?
Yes. But again, like there's a possibility where you can get something like this that's weird, where they're both horizontal tangents or something at the same point.
Mm-hmm.
They're not continuous. So you really need to check both.
Okay.
I guess is what I'm saying. I would recommend doing that. But if you're trying to exclude it, you check continuous first.
Okay.
Okay, 55 is next. Wow, there's a whole host of instructions here. All right, let me snip it in. Hey, happy Halloween.
Thank you.
Yeah. Said that to a guy at the golf course today, and he's like laughing.
I'm not doing anything.
So, okay. Determine whether the function is differentiable. That basically is like, can you take the derivative of it? So as far as you know, like everything in the world is differentiable. Let me graph this real quick so you can maybe see the oddity here. And then we'll actually take the derivative and you can see it.
Continuous means that there's no like holes or anything like
jumps,
that.
No holes, jumps, asymptotes.
Differentiable is like, how would you describe it? The
tangent line from the left is the same as the tangent line from the right.
Okay.
because it's continuous, they're the same.
Right, okay.
Okay, so right here at 2, this is called a vertical tangent.
Mhm.
And we're going to see that when we take the derivative here. But sometimes seeing the graph at first helps you to understand like what you're looking for. So essentially, you're looking for where is the derivative undefined. So undefined, kind of two possibilities, division by 0. Okay, that's kind of the main one you're looking for. The other one is like square roots of negatives, but division by 0. So f of x is equal to, I'm just rewriting it, x minus 1 to the 3/7 power. If that's unclear, remember the square root of x to the 1 is x to the 1/2 power. The number inside goes in the numerator, that number outside goes there. That's how I would remember that. So this is a power rule derivative.
Okay.
So we got 3/7, x minus 1, subtract 1 from here. So that's negative 4/7.
Oh, from the fraction.
Yep. You have to subtract 1. And then you multiply by the derivative of the inside function, which is 1. Could be something else, but it is 1 in this case. So you might be saying, well, hey, Matthew, you said division by 0. Well, you have to rewrite this. And this is where, this is really a good test of like your prerequisite knowledge in this class. So this is 3/7, 1 over x minus 1 to the 4/7 power, just moving it to the bottom. Okay. And then if you just rewrite the root, it's the 7th root of x minus 1
To the
to the
fourth.
4th. So you divide by 0 when x equals 1. So you would conclude, the conclusion is it's differentiable everywhere except
1.
except x equals 1.
Okay.
Okay, that's part A. Let me go back to, so that's part A. Continuous but not differentiable. So that's where, like, once you have the graph, which I know you wouldn't have, but like you kind of do need to know some things about the graph. Or you need to know that this is like good everywhere, this original function. There's no weirdnesses, there's no jumps, holes.
How do you tell a jump in a hole just from the?
So those come from
The number.
rational functions, like something over something.
Oh, like a fraction?
Yes, which we kind of have in the derivative, but we already handled that kind of. I know it's not a great explanation. You should assume everything is continuous everywhere until we see something that isn't.
Okay.
So to answer part B, continuous but not differentiable. Continuous but not differentiable. That's the case here. It's continuous everywhere. Okay, and the only place it's not differentiable is at 1. So the answer to B is like everywhere. So let me try to clarify. Let me.
Oh, because the only place differentiable is 1. So then.
Yes. So the answer to A, let me not, this is not the right way to write it. It's minus infinity to 1, comma 1 to infinity, and B is minus infinity to infinity. That means everywhere.
Okay.
So that's that. So then part C says neither continuous nor differentiable. That doesn't apply here.
Because there's no point, where it's.
Yeah, like that would be like an asymptote.
So that would be those answers, like C would change if there was a point when it's continuous but not differentiable.
This one's neither. Like, it's always weird. So it's not one or the other.
Right. Okay. Okay.
So like the C doesn't apply to this one, and we would need to see another example to be able to say when it would apply.
Right. I just don't know like how to find like the jump hole like vertical from if you don't have a graph,
Yeah. Well, it's not. I mean, so you have a day or two before your exam, right? You said it's Wednesday. I mean, hopefully you'll see your instructor. I mean, I would ask and say, look, I did 55. I understand 55, but like, I know there's a lot of other functions out there besides these. So like, what what should I expect? And
Right,
maybe that will give you some guidance on that.
okay.
Okay, number 61, hitting the slopes.
Okay.
Okay. Let me snip this in one at a time. Okay, differentiable function f has the property that f prime of x is greater than 0 for all x. So what that means, what that first sentence means, is that it's always increasing, meaning it's always going up and to the right. So something like this is always increasing, for example.
Mhm.
I mean, there's others, but it's, it could be like this, but it's always going up and to the right somehow. I mean, it literally could be a straight line too. The line y equals 3x minus 2 is tangent to the graph of f at the point where x equals 2. So if we don't know, we have no idea what this graph looks like, but at 2, when x equals 2, y equals 3 times 2 minus 2, which is 4. So at 2, 4, we know that we have no idea what the graph looks like, but we know that it has a tangent line that looks like that. Like we don't know whether the graph looks like that or that. We have no idea, but it doesn't really matter. Okay, but that's what this stuff is telling you. Okay, so we know it goes to the point 2, 4. The tangent line always touches at that point, and we know the slope. What's the slope of the line?
3.
3. Okay, so now we want the normal. The normal is obviously 90 degrees. So how do you get the normal from this?
It's negative 1/3.
Yeah. So the normal has a slope minus 1/3, and it goes through that point there, minus 4x minus 2. Yeah, so it's got this kind of shape to it. That's that line there.
Mhm.
Is that clear?
Yeah, is that the whole, that's the only thought?
No,
Yeah.
there's part B. Part B.
Oh.
I don't know what that is.
That's an easy question. Okay, that makes sense though.
Find the equation of the tangent line of the graph of G inverse. What is G inverse? At the point where y equals 1. What is G?
Can I only give you F?
Let me look here at oh, I'm sorry, I grabbed part B from the wrong question. Okay. Okay, here we go. Find the equation line where the graph, or the line of the tangent of the graph where y equals 2. Okay. Find the equation of the tangent line of the graph. Okay, so I think this is referring to, I want to say it's referring back to this line right here, but because it's like f inverse of 2, oops, sorry, f inverse of 2, which is 4. It's that point right there. So it's asking for like one of these lines, and it's probably the normal line. So I'm just gonna take a guess that it's referring to this one there, but and the reason is because the this line y equals x. I mean, that's how your inverse is created.
Okay.
But I'm not completely sure. I mean, this is kind of weird. We could, I guess we could find the inverse. No, we can't because we don't have the original function.
So basically it's just your,
Excuse me.
the point, you got 4 because that's,
That's from this point.
so would it always, here, do you want me to check what the answer is in the back?
Yeah, why don't you check on this one? And maybe that'll help explain what's going on here. The next one, part C is pretty clear.
So 61,
Yeah, 61B.
it says it's y minus 2 equals 1/3 x minus 4.
Okay,
Oh, because
so
you're trying the equation.
okay, so what they're saying is that the derivative of the inverse is equal to 1 over the derivative of the original is the slope. So this is like a definition. I don't know if you did inverses in this class for derivatives.
I think we did, yeah.
So you take the derivative, but your derivative is always 3. That's how you got this 3 here. So that's how it becomes 1 over 3.
Well, isn't it just the like, oh, it's not the opposite reciprocal.
It's not, and that's why this is, I mean, this is maybe out of scope for your exam, but this is a definition. ddx of the inverse is 1 over the derivative.
Where was the derivative? Where did we get that from?
Well, we don't actually know. We just know that the derivative has a tangent line here. So the slope is 3, so we're assuming it's that, which isn't quite right, but we can go with that for the time being. Okay, so if that's true, okay, great. And then how do they get the points? Well, when y is 2, they're saying x must be 4. And that's how I heard. I think you said y minus, I'm sorry, what?
Y minus 2 equals
Yes.
1/3 x minus.
Sorry. So what happens is that x and y are flipped, which is here, but we're still using that point. So, but it's flipped.
Okay.
With the inverse. So that's where it becomes y minus 2. It's 1/3 x minus. Is that what you? Yeah.
Yes.
Okay.
Okay.
Okay. I bet a lot of people in your class have questions about that one, especially if you haven't done inverses. So, maybe ask on that what the instructor is expecting. Part C we can definitely do. So the equation of the tangent line. So more generally, the tangent line requires 2 things. It requires a slope, which comes from the derivative, and 2, it requires a point. So we're going to first get the point.
Well, don't we already know this slope is 3?
But it's a new function. It's f of x over x. So the point, when x is 2, it's y equals f of 2 over 2.
Okay.
And f of 2 we said was 4 because we did that back here. 3 times 2, 6 minus 2.
You still use that even though that's not the function you're using?
Yeah, we don't know the function, but we know it's tangent at that point. So that was the whole point here of this graph, is like, we don't know what the graph looks like, but we know it touches, like right there, it touches. So that point's golden. It's a perfect point for us to use.
Okay.
So sometimes you can't overthink this stuff in this class. Like you say, well, I only have this point, so I must be using this point. Okay, so f of 2 is 4. That's where that comes from. And then you're just putting 2 in for x. So that equals 2. So when x is 2, y is 2. So you have a point now. Your point is 2 comma 2. To get your slope, you have to take the derivative of this. And this is quotient rule. So it's bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared.
Yikes. Okay.
Yeah. So again, maybe out of scope for what you guys are doing. But it is doable. So you have your x value is 2. So it's 2 times f prime of 2 minus f of 2 times 1 over 2 squared.
And that's 2 times 4. Or no, it's not.
That's 3. That's the slope. That's the slope of the tangent from the original.
The f prime,
Yes.
that's
So-
6.
So right up here, the line y equals 3x minus 2 is tangent. That gives you the slope of the curve.
Okay. So
I
it'd
know
be,
it's a lot to take in. And this is a pretty tough problem,
so it'd be 6 then.
right? And then f of 2 we just found is 4. Comes from the original function, so it's 6 minus 4 over 4, which is 1/2.
Well, isn't it, what about the 2?
It's
2
f
is,
of 2.
no, isn't it 2 times 6 minus 4?
2 times 3.
But isn't it 3 times 2 because
No,
it's
it's f prime of 2.
f prime of 2 is 3?
Yes. So f prime is the tangent line slope. So the tangent line was y equals 3x minus 2. So the slope is that number right there.
But then what about the, like, don't you have to like multiply it by 2 because it's f prime of 2, not just f prime,
The f prime is the derivative is a function.
right?
So you evaluate the function at a point. But
So that's at the point like x equals 2 or something?
yeah,
Like what,
exactly.
okay.
Exactly. Sorry, this whole thing is 3.
Okay.
And this whole thing is 4.
Okay.
So now you have your point and your slope, so you can write the equation. You need those two things. So your slope is now 1/2. And you say, okay, it's y minus 2 equals 1/2 x minus 2.
Okay. I see.
I don't think I would have understood this the first time I saw it. So there's no expectation that you fully understand this right now.
I understood the first part.
Okay, that's great. That's great. So it's hard to do one. I mean, 62 is kind of like it, but let's see, 67. What does 67 look like? Okay, 67 is a really good one for us to do. Really good. This is a classic exam question that you will see on your exam if you have a good instructor. It's really testing your knowledge of derivatives. So they give you a table, great, and then you have to take the derivative of this thing right here, okay, and then you have to evaluate it. Okay, so this is a quotient rule. And you're probably uncomfortable because there's an f of x on the top. That's okay. You're gonna go with it. You're just gonna take the derivative. So your derivative is bottom times the derivative of the top. So the derivative of the top is f prime of 2x chain rule times 2.
Okay. Over.
Minus, you got the top now, the rest of it. So what's the derivative of the bottom?
Just x. No, I don't know.
Just 1.
Okay. And then
Right.
it's x minus 1 squared.
Yes. Yes. Now, very important that you put the number 0 in. So for x, and then just like see where you're at. So it's 0 minus 1, f prime of 2 times 0 times 2 minus f, excuse me, 2 times 0 over 0 minus 1 squared.
So -1 times 2.
F prime of 2.
Yes.
And this 2 comes out in front. Minus f of 0. I'm sorry, this is f of 0. Sorry, f prime of 0.
Yeah, and then -1 squared, so just 1 on the bottom.
Yes.
Okay.
Okay. Over 1. Right, -1 squared becomes 1.
Yeah, just
okay, so now you got to go back to your table and you got to find f prime of 0. F prime of 0 is -2. F of 0 is -1. So it's -2 times -2 minus, I think I saw there -1. Yes.
Over 1.
Over 1 if you want. Okay, so that's 4 plus 1. This ends up being 5.
So that's like your what? Is that your slope or is that just
Yes,
a point?
that's
Okay.
your slope of f of 2x over x minus 1 at x equals 0.
So then that's also isn't it also like the derivative because slope is the same as the derivative?
Well, yes, it's the derivative at this particular point, the slope
Right.
at this point, yes.
Okay.
Okay. So there's a bunch here. We should do most of them. I guess we'll go B next. And I'll bring the table down, or you've got it in front of you. The really the important thing is being comfortable taking derivatives of like functions when it's not x. And one thing here that might help is this is really f of x squared g of x cubed. Oops, put that right there. So this is a product rule. Because you got two functions multiplying each other.
Mhm.
All right, so I can't remember how we do this, how you like to do this. Do you like to keep the first and then take the derivative, or derivative of the first?
Keep the first.
Okay, so your derivative here is keep the first. Okay, I'm going to keep the first exactly as is. Then I'm going to use a power rule here. 3 g of x, 3 minus 1. Now I got to take the derivative of the inside function, g prime of x.
Right.
So before we move on, let's just be very clear. This is f of x squared. Okay.
Wait, so is the extra g prime of x, that's like chain rules,
That's
right?
exactly. Yeah. Chain rule. Yep. So 3 g of x squared times g prime of x
Okay.
plus. Okay. Now you got to take derivative first. 2 f of x, 2 minus 1,
f prime of x.
f prime of x, and then you keep the second, g of x cubed. So plus 2 f of x to the power of 1 times f prime of x times g of x cubed.
A long problem. Okay,
And
so now you plug in 0.
It's at x equals 0. So f of 0 squared, 3 times g of 0 squared times g prime of 0 plus 2 f of 0 times f prime of 0 times g of 0 cubed.
So then you look at the table.
You just substitute in numbers.
Okay, so we need f of 0 and f prime of 0.
Yeah, so f of 0 is
0 and g of 0. I don't know. I don't have the table.
Okay, so I'll just give you the numbers here. Let me. So sometimes, let me go grab it again. Sometimes the hardest thing is actually like putting the numbers in the table. So I do think there's a bit of a skill there to be able to do that comfortably.
So f of 0 is, wait, I need to, -1, and then
Right.
g of 0 is -3.
Okay.
And then g prime 4. Well, that's -1 again.
Okay.
F prime is -2. And then -3.
Okay.
So then that's 1 times -9 squared, which is
No, you got to square first.
So 18.
Yeah. No,
Oh
it's
no, not 27.
27 times 4 plus these you can multiply. So that gives you
Positive
4.
4.
Yeah, 4. And then -3 cubed is -27. So it ends up being 0. Not. Yeah, 4, because whatever 4 times 27 is,
You cancel it out.
Yep.
Okay.
Okay. If that was clear, we can do C. C is not as difficult.
Is this all from the same problem, or is this a different problem?
Yes, it's all the same problem.
Oh.
Okay, so here, this is just complete chain rule. Because you have outside function and then you have an inside function. So see if you can do this on your own, and then I'll jump in and help. This will be a good one for you to try.
Well, do you not start with the power rule?
There's no exponents here.
Oh, okay.
That's why it's pure chain rule.
Mm,
All right, so let me jump in here. It's G prime, keep the inside function, times the derivative of the inside function.
Do you? I see. Okay.
Yeah, so now it's G prime of f of -1 times f prime of -1. So got our table. Let's go up to the table here. So f of -1, f of -1 is 0. So this becomes G prime of 0. And f prime of -1 is 2. G prime of 0 is 4. So this ends up being 4 times 2, which is 8. Now, we're going to do one just like it here for part D.
Wait, why are you saying like check mark? What is the?
Oh, sorry, just
Oh,
done,
just.
done. Sorry,
I thought you were like checking it with something.
get that out of here. That's no good. Okay. Part D is the other way around. It's excuse me, it's f of g of x, f of g of x at x equals -1. If you could give this a try, I'll just step away for 30 seconds and be right back. All right, how are you doing on this one?
Okay, so I'm just finding the values in the table right now. G -1 is -1 of G prime of 1. Yeah, that's where I got to. So how did you get the 2? Where did that come from?
F prime of -1. So f prime -1 is right there.
Oh, I see. You have to go back to the table like again. Okay.
Yes, you just keep going back to the table. If it's not in the table, you made a mistake, or your instructor made a mistake in the exam, but they'll probably just grab something that they've already found before.
Okay. I got it.
Let's let me look here. 67. Can we go to 72 and 81 and come back if
Yeah. That's fine.
although truthfully, like your 72 is way out of scope. I mean, you're getting to questions you probably won't see on the exam. 81 is probably a good one to do. Because they're AP exam questions. I don't know. Do you have to do these, or is that the
Yeah, we have to turn them in.
okay,
For
okay, okay.
credit.
Well, let's do 72. No. Okay.
Oh.
Okay. Blah blah blah. There's a function here, and you have to take an implicit derivative. So whenever you see x and y's, you should start thinking implicit derivative.
So implicit derivative is just like the y prime stuff, right?
That's right. So I want you to take a chance, take a
this.
shot doing this. I know you can do it. Give yourself 30 seconds and see how you're doing on that. so I'm just gonna start writing here.
Okay. I didn't write the -0. Is that?
Yeah, you don't need to. I
Okay.
wouldn't normally either, but the main thing here is I want to make sure, like, if you want to make that -2 part of the XY, just be careful you distribute to both. That's a common mistake that you'll see here. And I don't want you to do that on the exam, obviously. So you're gonna move the non-y prime terms. Okay, so it's gonna be and I'm actually gonna reorder these because you generally want the positive out in front. And then it's gonna be 2y minus 4x.
Okay.
So from there, you factor out y
Y
prime,
prime.
2y minus 2x.
And then divide
And
by
then you divide.
2y.
Yeah, now this one reduces, and there is somewhat of an expectation that you reduce. Everything is divisible by 2. So you divide everything by 2. It'll help with the next part of the problem, which is the only reason you would simplify is if you have to use it again.
Okay. Well, we still haven't found the.
Yeah, we're gonna get there. Yeah. Okay, so it says part A. You're up
All
to
of
here.
that just to get to part A. That's
Yes. All right, find the coordinates of points A and B where the tangent lines are horizontal. So this, as you've asked and said many times, this is the slope. This is the slope function. Like if you give me an x and a y, I give you a slope.
Yeah.
So it's horizontal when the slope is equal 0. Horizontal means slope y prime m, all those things equal 0. Now when it's rational like this, it's when the numerator equals 0. So you have to set the numerator equal to 0. So you set y minus 2x equal to 0 and y equals 2x.
Yeah.
You're like, well, that isn't very helpful. You're right, it's not. But we're going to put that back into the original function.
Okay.
Okay. And we're going to solve for value. So wherever you see a y, you're going to put in 2x. So 2x squared minus 2x times 2x plus 2x squared minus 4 equals 0. So wherever you see a y, you put in a 2x.
Okay.
Okay, 2x squared minus 4x squared plus 4x squared minus 4 equals 0. That's just simplifying that line there.
Just 2. It's just 2x squared.
It's just 2x squared minus 4 equals 0. Solve for x. There are two values.
Put 2. I can't do that in my head. Okay.
Plus or minus square root 2. Excuse me. So the reason there's two values, if you go back and look at the question, it says find the points of A and B. So B is positive square root of 2, and A is negative square root of 2.
How do you? Oh, because they're in the. I was going to say, how do you know? But they're in the quadrants.
Right. So to find y, since y is 2x, you can use that there. So the y value is 2x. So y is equal to 2 times plus or minus square root of 2. So you get the other value from it.
So is it just 2 root 2 then?
Yes. So this point up here, b is square root of 2 comma 2 square root of 2. And a is minus square root of 2 minus 2 square root of 2.
Okay.
Okay, so part B, where the tangent lines are vertical. So that's where
that's equal to 0 as well.
The bottom is equal to 0.
Oh, okay.
Okay, so the bottom equals 0 and y equals x. Right?
Okay. Yeah.
Y equals x. That's the vertical. Okay, so you go back to this thing, this horrible thing here, and you substitute in y equals x. Okay, so go ahead and give that a try. See if you can come up with the points.
Oh.
Okay, so let me just start here. You're welcome to just keep working.
Well, I got x equals plus minus 2.
Oh, good. Okay, so you get 2x squared minus 2x squared plus x squared minus 4 equals 0. So yeah, x equals plus or minus 2. And then your y is right there. So y equals plus or minus 2. So
That's nice.
yeah, that one was a nice one. We should have done that one first. But now you have those points.
So that's C and D.
Yes. Yes.
Oh, okay.
Okay. Yeah. So lots of good things in here. Like you got to be comfortable taking your implicit derivative.
Well, so sorry, 2. So D is 2 comma 2 and C is negative 2 comma negative 2, right?
Yes.
Okay.
Main thing though is you got to make sure you understand that where the numerator is 0, that's where it's horizontal. Where
Right.
the denominator equals 0, that's where it's vertical.
Okay.
Okay, we can move on to 81.
That's the last one on the
Yeah,
list.
this one's got a lot going on, as usual.
Okay.
More symbolic questions. Those are a little bit tougher. Okay, function at its first derivative defined for all real numbers. That's given that f of 0 equals 2, f prime of 0 equals 3, and f double prime of 0 equals -1. Define a function of g by g of x equals e to the kx plus f of x, where k is a constant. Find g prime of 0 and g double prime of 0. Show your work. Okay, so basically, you just need to take g prime. You need to find g prime of x. So you need to take the derivative of this right here. So the derivative of e is,
Isn't it E? It's just E.
it's itself times chain rule. So what's the derivative of k times x? Like imagine it was 3x, it would just be
This K.
plus,
It was just 3.
yeah, f prime of x.
Okay.
Okay, so it says find g prime of 0. So g prime of 0 equals e k times 0 times k plus f prime of 0. Do we know f prime of 0?
Yeah.
Yes,
No.
we do.
Yes, we do 3.
Yeah, it's 3. So this is plus 3. E to the 0 is 1. So this is k.
What's K?
We don't know, but it says in terms of k. So your answer is k plus 3. You're done here.
Okay.
Okay, so now we're going to take a second derivative.
Oh my god. Okay.
You can do this. It's not a big deal. It's g prime of double x, g double prime of x. Now it's maybe it's better if it's written this way: k e to the kx, but k is a constant, so it's k. What's the derivative of e to the kx? It's itself
The KX.
times k.
Okay.
That's the chain rule part. Like whatever is inside, you have to take the derivative again.
And then
Plus,
is it F double prime of X?
exactly.
Oh, so then you have that value. I
So
see.
g double prime of 0 equals k squared e to the k times 0 plus f double prime of x is -1. So g double prime of 0 equals k squared minus 1.
Because it's E to the 0, right? It just turns into 1.
Which one?
E to the 0.
E to the 0, yes.
That
Yes.
turns into 1.
Okay, so that's part A. Part B, What is part B? So it's kind of the same thing. It's just a different function here.
Is e to the 0 just 1?
Yes.
Okay.
E to the 0 equals 1, always, no exceptions.
Okay.
Okay, so h of x is given by this.
Okay.
And so they want to find h prime of x. When you look at this, I know it's got symbolic and it's got functions, but do you see that it's a product rule?
Yeah.
Yes, that's critical here. This is product.
So it's cosine bx times f prime of x
Okay, good. Plus
plus f of x times negative sine bx.
a little more. What's the derivative of the inside
Times
function?
b.
Yes.
Okay.
Okay, now tangent line means you need two things. You need the slope and you need a point. So we can get the slope here because we're going to put 0 in. So h prime of 0 equals cosine of b times 0 times f prime of 0 plus f of 0 minus sine b times 0 times b.
Oh my god. Okay.
A lot of this is going away. What's the cosine of 0? 1.
1.
Unit circle. You got to know your unit circle, especially those nice points, the ones on the 0, 90, 180, all that.
Yeah.
F prime of 0 equals 3.
That's
Sorry, probably a lot of your teachers tell you this, like, oh, you got to know this. Like, I know there's a lot you gotta.
Is f prime of 0, that's given, right?
That's given.
Okay.
F of 0 is 2. That's given as well. And then this is minus sine of 0 times b. Sine of 0 is. So what's the y value right there? That's what I'm asking.
0.
0. So this all goes away. Right?
Oh.
2 times because you're all multiplying. So this right here is 0. So this whole thing goes away. So it's 3 plus 0, which is 3. So that's your slope. You got your slope.
Okay.
Point you get from putting 0 back into the original, which we should have done first, but so I'll do it up here. H of 0 cosine b times 0 times f of 0.
So then cosine times,
Yes.
well, what's your b?
So what? Well, it doesn't matter. What's cosine of 0? What's the x value here?
Well, cosine of 0 is 1.
Right, and then f of 0 is given as 2. So this equals 2. So when x is 0, y is 2. So now you have your point. So now you have your slope and your point.
So
y
it's
minus
y minus 2 equals 3 times x minus 0. Yeah.
Yes, you got it.
Oh, okay.
You're can't believe you did 2 hours of this. That's pretty
we finished
special.
it all just in time.
Yeah, well, we didn't get done. There's 2 more parts of 67.
Oh, there is. Well, that's fine. But that was the one with the table, right?
Yes, and I mean, I'm sure you have them in the back of your book if you need.
Yeah, and I can figure those ones out, I think.
Yeah. So look at your unit circle. Will probably be a good takeaway if you have time. Look through that again. Make sure you're comfortable with that.
Yeah, I have another lesson I think tomorrow. So.
All right. Well, thank you so much. Appreciate you scheduling, and
thank you.
I'll see you tomorrow. Talk to you tomorrow.
See you tomorrow. Bye.
Okay, have a good night. Bye.